So while we are on the topic of quality on video streaming, our next talk is also talking about quality in a similar sense. So welcome, Alex from AVEC.
Yeah, thank you very much. Here's the pointer. Thank you for the talk before. So you explained a lot what I actually wanted to explain. So probably we can hop on a bit quicker. And I like the idea about selecting the rebuffering statistics, because this is pretty much what we are doing. Let me introduce myself. My name is Alexander Martin Dethoff. I studied computer engineering at the Technical University of Berlin. And during my studies, I co-worked at the innovation laboratories of Deutsche Telekom in the space of network quality monitoring, with a deep focus on video streaming. And after my studies, I co-founded with my former co-workers, Werner Robitzer and Alexander Rake, a spin-off, where we continued to work on these topics and do more analytics for that. And it's pretty much research-driven, and we wanted to find a good indicator to really understand what does it actually mean when a user at home will say, oh, my internet is not working. It is slow. When you go into the traditional statistics, the speed test, the ping test, the line is always up. So what does it actually mean? And it is that the user sees something when he is browsing the web and would say, from this point, this is wrong. This is not my internet. I want to change my provider, or I want to call customer support, or anything like that. So today I want to talk about the so-called measurement gap of ping and all its friends. So a short rebrief how streaming itself works. We have at the server side a video that we want to send out. And before we bring it to the viewer, we split it up into different kinds of resolutions. And as already told in the talk before, these resolutions are then split up into different kinds of timed segments, which we call the chunks. And the player on the client side will then, due to an algorithm that is player-specific, select which of the next segment it will load and then show to the end user. And the question is, why is it that complicated? Because we don't want this guy. Yeah. So the player algorithm can detect how's the network, or can make decisions and assumptions about the network, and then say, okay, now I will switch down to a lower resolution because it has less packet size, and so I can ensure that the player out goes smoothly and I have no interruptions. The bad thing is then when there's really an interruption, which we call then the stalling. So let's analyze, based on the ISO stack, where does the buffering actually happens. And I mean, this is here an event of the network industry, and people will probably correct me and say, well, your ISO stack has 8 layers. It actually has just 7, and that is true, because the stalling happens up here. The application layer has official definition, something like HTTP, FTP, but there's no definition like there's a Netflix protocol or a YouTube protocol or TikTok protocol or something like that. But the users are using these services, which we call the over-the-top services, and the buffering and any quality degradation happens up there. So it is the interface to the user. And when we check out where are the traditional metrics currently located, they're somewhere down here. Packet loss, jitter, latency, so you all know these metrics. And I don't know, probably somebody of you has already heard about the new QoE protocol. Anyone? Okay, so I don't need to explain. You know that the packet loss control mechanisms are moving up. So more to the application layer and less control about packet losses in the transport layers. So can we somehow derive the quality, what happens at the application layer, from the classic metrics? And therefore, I brought for you a simplified study, which we did a few years ago, which was a simple start just to understand what is the influence of the download speed to the time that a video starts to load, or it starts to play. So the moment that I really see a moving picture. So it's not like a time to first byte, it's really when I see that there's something happening. And in principle, you see this time is declining the faster my internet is. This seems to be clear. But what is interesting is that it's not a linear function. So the initial loading delay, or the startup time, is increasing more extreme the slower my internet gets. So the quality of experience is not a linear function of the quality of service. And we wanted to learn more about this. And so I wanted to show you how we did it to understand a bit more on this. The principal idea is that we wanted to build up a system which is able to monitor continuously any over-the-top service, and it will interact with it via browser automation and capture everything that happens in the video, in the player, on the network, and then it will translate all this data into an understandable value so that I can, in the best case, see with one view, okay, everything is fine, check mark, or there's some issue. So I brought to you a simulation that shows you how it in principle works. We call up the different services, Amazon, YouTube, Netflix, all kinds of OTT platforms. We select the video which is loading. You see we pick up some values like the resolution, video bitrate, audio bitrate, frames per second. So things that happens in the players. And then we translate it to a so-called mean opinion score from 1 to 5. And the mean opinion score shall reflect the opinion that the user would have about the delivered quality. So, for example, next time when you watch a stream on YouTube, you can probably think for yourself, if you rate it on a scale from 1 to 5, where is the quality currently? And we put this all into software which we call SurfMeter, and built a lot of adaptations for different kinds of OTT services. And we recently also started to implement metrics for Google Meet and MS Teams, so also in the conferencing space. And we put the software into the network itself. So we didn't put it to the user at home, where we could do in principle, but we didn't want it to because we didn't want to have the Wi-Fi influence. We just wanted to know what is the quality actually in a network. So we put it to strategic locations, somewhere in the access network. And yeah, now I owe you something. This value I'm talking about, how is it working in principle? I mean, I could just take some dice and say, yeah, this is a mean opinion score between 1 and 5, I'm fine. But we wanted to have more reliability, more validity. And I don't want you to remember the exact name of the standard we are using. It's called P1203 by ITU. But what I like you to remember is that it's currently the only most validated model that can really take technical data, like I showed you before, audio bitrate, video bitrate, resolution changes, and so on, and transfer it into a mean opinion score that really reflects the opinion of a user. So there were a lot of studies done during the ITU standardization process with around 10,000 users watching over 1,000 streams of different kinds of distortions who had to continuously rate between 1 and 5 where's the quality currently. And this model is able to reflect this. And putting it all together, standardization requires a bit of time. So what happens when you do standardization? In the meantime, the technology evolves, and suddenly we have new codecs. So that means the standard doesn't work anymore for the codecs. So as I mentioned before, we are a research-driven startup, and we are cooperating with the university on that. So we started to retrain the model for that, so that the model itself is also feasible to use to work with the new codecs. And everything together makes then a so-called layer 8 data set. It contains then, as I said before, the behavior, what happens in the browser, the web page behavior, so like page load times, render times, the video itself, so the data around I mentioned before, network capturing, and so on. And for sure, the mean opinion score. And now I'd like to go with you into the hands-on part and show you some insights. By the way, this guy is not me. When we have a network, can we say, oh, in our network streaming works like XYZ? Well, let's check it out. You see here a graph where you see different kinds of services. For the first time, it doesn't really matter which service is which. But I took here the so-called initial loading delay, so again, the time that it takes to load a video. And you see there are variations between each service. This guy here, this is YouTube. And YouTube is super optimized. So when you call up YouTube in a bad network, usually YouTube is still able to play out the video, and the website is behind in the background still loading. So this is super optimized. This white guy here is TikTok. They had some issue that day. Don't want to consider now more on this. But what is pretty interesting is here the, what is this for a color? Purple, magenta, something like this. Yeah, they have the topic that we know prime time in the evening. So, like we heard before, there's a time when people suddenly get in and want to see more, and then during the night, the later night and the day, then in the morning, they're not watching that much TV or video on demand. So, for in principle, we cannot really say the streaming works in principle XYZ because each service is different. Now, what is the mean opinion score telling us? Oh, sorry, I forget. And remember, this is the poor quality of the network itself. It's not Wi-Fi related. Yeah? So it's really in the network. So now, what is the mean opinion score telling? As you see here, this is a service where the mean opinion score is around a 4.3 with one glitch, but let's ignore that for now. And at the beginning of July, the mean opinion score starts to slowly decline. So this means if I would ask the viewers of the service all over in Germany, how would you like the experience of the delivered stream on a scale from 1 to 5? Where would this value be? And they tend now, from July on, name a lower value. Can we see this somehow in our data? A reason for that? And you see, yes, there are more stallings. Suddenly, the average number of stallings is increasing. And stallings have an impact on the quality. What do the traditional metrics say? The traditional metrics are, in this case, like speed monitoring, the ping tests, and the video response time. So video response time is like the time to first byte for the first segment of the video. And as you see here, the speed is pretty solid. The ping, it's sometimes we have some outliers, but it's in a range of milliseconds, so that's okay too. The video response time is also pretty much in a good road, so we're here also in a lower second segment. So based on this traditional metrics, we cannot see why is now the quality declining, noticeably for an end user. But luckily, we were recording also the player version. And we saw that there was a player update. And this player update had some internal algorithm bug. So instead of doing now a lot of network analysis and wasting hours of phantom troubleshooting, in this case, we could really verify, okay, this had nothing to do with the network, it has nothing to do with the Wi-Fi. In this case, it was really the OTT. So, in this case, nothing to the network, but are we safe anyhow? Oh. I never heard that this video had sound. I wanted to introduce now these guys. And yeah, we measured also Netflix. And as you can see here, in principle, I have here the video response time, which means the time, as I told before, like time to first byte, when the first video bytes are served, compared to the time that the video starts. And in principle, you see the faster my server can respond, clearly, the faster my video starts. But suddenly, you see here a gap. It's around this value. Suddenly, the startup time jumps for 2 seconds. I mean, in case of Netflix, maybe people will be a bit more tolerant because it's movie night, everybody's relaxing, and if they wait 2 seconds longer, probably. We don't know. But the question is, why is it suddenly jumping up? And the reason is that Netflix, the Netflix player, has some internal algorithm which is continuously checking back the servers that it wants to connect to and doing ping to them. And depending on the ping response time, it will then choose which server is the fastest one. And if, for a certain threshold, they tend to answer slower, Netflix may decide to buffer more before they start in order to ensure a smooth playout. So this can suddenly, a ping that is suddenly only a few milliseconds longer than usually, may has already an impact for 2 seconds loading delay. Now more and more providers are switching to multi-CDN strategies. So you have on the server the video that you want to send out, and now the provider is using different CDNs to bring it to the viewer. And the question is, which of the CDNs are selected? And when we select it, the question is, do they all deliver the same quality? And therefore, we did some analytics where we analyzed multiple CDNs. I brought 2 of them for you today. And we captured the mean opinion score over the time and did a distribution. So where is the mean opinion score, in fact? And you can see this blue guy here tends to have a lower mean opinion score. And I mean, we usually say that everything up to 4 is perfect. So we don't need to be in a 5 region. 4 is already good. So everything below is critical, or gets more critical the lower it gets. And you see this guy is really tending more going to this side. So yes, in fact, the CDN can have an impact. So the question, as network guys, what can we do? We don't have really a choice which server is selected. But what we can do is to shorten the peerings, to set the peering locations, and we can set on-net caches. So, for example, Netflix, they provide the possibility that you can put a server directly into your network, and it will cache the most available videos, so that, in fact, when a user in your network wants to watch Netflix, he's probably taking a stream that is on this cache server, and you don't have to transit somewhere. You can directly serve the video from your own network. And as far as I know, Netflix is doing this for free because they also have an interest to make their customers happy. Oh, wrong button. And finally, we can improve our inner network capacities. I removed the sound, but okay, probably not. I want to go to the conclusions. So first of all, understanding QoE requires the so-called layer 8 view. So traditional network metrics won't get replaced by a layer 8 view, but it's a complement. So to understand modern streaming issues. And valid models for the mean opinion score can help you to better understand impacts of network decisions and also find out, is the issue now to the network, Is it to the player? Where is the actual issue? And as I mentioned, fast wins exist. So you can host an on-net cache, you can check the quality, and improve the network lines. My final 2 cents are, it's not always the Wi-Fi. The future grows quick, so many of you know the quick. So packet control will move up, and the insights will change. And last but not least, QoE is a cool topic. And with that, I'd like to conclude this talk. And as I'm more working on the application layer, I'm really happy to be here and also learn from you how these issues affect you, or if you anyhow have to handle them. And therefore, I'd like to thank you for listening. I hope it was interesting for you, and let's keep in touch. And I'm curious to know more from you.
Thank you, Alex, for that talk. Again, we have some time for questions from the room or from Venuless, if there are any. I see one hand.
Yeah, hello. Question in regards to the algorithm that you use. So it seems to be very focused on video traffic. Is there any published information on how the calculation of the mean score works? And have you thought about also, let's say, translate it to other services other than video streaming?
Yeah, so I'm not sure if I can move this here and quickly. I can give you some more slide about the calculation. Whoop. Whoop. Next one. So the OTT model itself is split up into different segments. As I showed you, we take the data like the resolution, frame rate, bitrate, and so on. And we can put this into different modules. And we split it up into an audio module and into the video quality module. And these modules, they compute the mean opinion score per second. And this is just for a short time based on that thing that I told you the mean opinion score was calculated, or the model was developed, that real users had to watch video. So I couldn't let them watch distorted video for a long time. So in this time, this is just a short-time analysis for 10 seconds. And then we integrate it up with the buffering event data into a so-called audiovisual quality model, which holds for 5 minutes, outputs, and bring them the final mean opinion score. And then we use a moving average over the full movie length to see where the 5 minutes now, to get a better impression on that. The model itself is kind of a mixture of ground truth research and ML-based learning. So there's also a paper. If you like, you can send me later an email, and I will send you the link to it. And the question, if we thought to go beyond the video part, in this case we're concentrating a lot on video because it's consuming the most of the traffic. And it's the thing where people will mostly see that there's some difference. If my web page is loading 1 second longer than usually, they won't probably even notice. So this is why, I don't know if you remember, I showed before that we are now also doing with MS Teams and Google Meet. So this is where we are currently investigating if there are possibilities to measure the quality also for such kinds of services.
Okay, thanks.
Thank you. Do we have another question? Oh, I don't think so. Well, thank you for your talk.
Okay, thank you too.
Big applause.